All right. So the first 14 chapters of the player's guide here go through the basics of C#. Like, you've never done C# before, so let's talk about what C# is and different things. Definitely worth flipping through. Hey, can you mind grabbing the door for me? It's just a little loud. Like, what is C#? What is .NET? Getting the IDE, using Visual Studio, those sorts of things. Your first project. So it takes you through all the basics here. Really quick to flip through. You don't have to read it all, I promise. Comments, skip that chapter. We don't need comments. They're worthless here. Variables work the same way they do in C++. We'll look at all that in a minute. Different types in C++ or C#. Some basic math stuff that we'll pick up here as we go. Using console, instead of C in, C out, we use a console class. It has all that stuff built in for us. Using if-else, relational things, Boolean operators, those sorts of things. The conditional operator, our ternary expression. This is the easiest way I find people who cheat, is they give me ternary expressions. That's the stupid question mark and then a colon. No one ever writes those in CIS 150 unless you make them. So when I get code with those in it, I'm like, you didn't write this? And they're like, no, I didn't. So anyway, switches. A lot of things are going to be very similar. So we're just going to breeze through. This is what it looks like in C#. I don't need to teach it to you. I just want to show you. Here's an example real quick. And you can go look in the book for more. Is that a question? No, okay, sorry. Arrays work basically the same way, but they're better. They have more things we can get. We can actually find out the size of an array without having to do the size of and divide by things, right? Who knew you could like build it into your language and make it easy to use? We'll get into methods and then briefly memory management in C#. Just real brief at the end here, looking at the stack and the heap and cleanup here. Because it's a managed language, it generally does a very good job of this for us, which is really nice. So did anyone use auto pointers in C++ at all? Oh, I thought you raised your hand. I was going to be excited. So the idea with an auto pointer is it knows when it goes out of scope and cleans up after itself. Right? In C++, we figured out how to do this. We just don't show you for some reason. I don't know why. So you don't need to make sure we're deleting things and deallocating the memory so it can be freed up here. Similar sort of idea. When your object goes out of scope, C#, the .NET runtime says, hey, operating system, you can have the memory back. We're not using it anymore. Works out pretty well. Right? So we'll get through all of that tonight. And then we'll talk about our first project, our first game. Game's probably the wrong word here, but it amuses me to call it a game. We'll get there. Don't worry too much about it. And then next week, not from the textbook, because I want to spend a little bit of time showing you the different graphical user interface applications. That's one of the other fun things C# does really well, is we get a nice little drag and drop interface for building interfaces. We don't have to do everything at a little black box here, because most of the time, users in the real world don't type in the black box. Right? They click on buttons and they type things into forms and they have drop downs and all sorts of fun stuff there. So we'll look at some of those fun bells and whistles. I'll show off Maui for fun. Supposedly works cross-platform on mobile and Mac and all sorts of good stuff. It's a bit of a pain. It's gotten a little bit better. And then we'll talk about XAML a little bit and we'll come back to XAML later. Yeah.
Are you talking about like CSHTML or like button.clickevent type stuff?
Yeah, that's all WinForms sort of stuff. Yep. Yeah. And then we'll pick back up into the object-oriented piece, part of C# here, writing classes and doing that fun stuff. So this takes about 3 weeks to get through for this object-oriented section here. There's a lot of stuff here that we're going to look at. Depends how much you've done before, right? You should have done inheritance before. You probably talked about polymorphism before. Those shouldn't be new terms, those sorts of things. We're going to look at how they work in C#, how we can use them. Interfaces are fantastic. C# developers love writing interfaces for things. They're great. It's a good way of designing. I think it's still a good way of designing things. Other people argue they're silly, but that's fine. You can have arguments with people. Any software engineer you want to start some arguments. And look at some other cool things. Structs and records and generics. How we do generics in C# is interesting. And then a couple useful built-ins here. Some other classes that are just part of the C# library we can use. You can do random things. You can do date and time. Date and time turns out to be one of the hardest things to do well in coding because date and time is such a weird relative concept. And then you have leap years and you have leap seconds and you have all sorts of nonsense with like daylight savings time. So you might think there's only 2 a.m. in a day. Turns out there's not. Right? When we have daylight savings time, sometimes there's 2, sometimes there's none. And you're like, well, how do I, like, so use the libraries, they've handled all that for you, which is the nice piece here. And then we'll get into the advanced topics a couple weeks after that. So the advanced topics, not quite as much time. We don't need to go super deep on these. but we'll look at some of these other things here. Delegates, events, lambdas, these are all really cool things. We'll look at files. Pattern matching is not super exciting. Operator overloading, you can do that in C# too. So basically anything you've done in C++, you can do in C#, but we get more bells and whistles, which is great because it's a nice language. Query expressions is going to look super weird, but we'll spend time with this. This will help us later on when we get to working with databases. Our language looks a little bit like SQL. If you've taken a database class before, SQL means something to you. If not, it's okay. We'll get there. And then we don't do a whole lot with asynchronous programming. There's a joke here. Async code. This was apparently at someone's office somewhere. Where is it? This one here. Oh, come on. All right, why is it so small? You must be this tall to write multi-threaded code. Oh my goodness, guys. I've been on my laptop screen this whole time. That's fantastic. Wow. I am so smart. This is what I get for flipping away. Okay. Yeah, I was showing things the whole time. It was the table of contents of the book, so you didn't miss a whole lot of interesting stuff. But this is the joke. Multi-threaded code is super powerful. Some can be rather complex, and it can really screw things up if you do it wrong. So great. And there's really cool things we can do in C# that make it a little bit easier for us to use. Our games at the end will actually be multi-threaded, but because the library takes care of all that for us, we don't have to do anything special to make it multi-threaded. It just is, and we're really happy. Right? Multi-threading stuff is fantastic. So that's what that one is. All right, back to, this was the table of contents I was going through. So, sorry. It's going to be on the recording though, because I was recording my screen. So if you're really bored and want to go back, you can see the table of contents that you missed. Anyway, unsafe code, you can do some weird stuff that is actually outside of the managed runtime. And really crazy things. There's a fun thing. If you join the Discord server, I just posted recently in the Interesting Stuff channel, some guy who likes doing minimized programming for fun, I don't know why, has a program that is less than 2 kilobytes. That's an executable that will run, and it's essentially a little 3D style maze that you go through, including graphics. Less than 2 kilobytes, because he went through all these steps of how I can get this smaller and smaller and smaller and smaller. Super cool. Again, if you're into that sort of thing, great. If you don't care and you just like make your programs do fun stuff, that's cool too. There's just wild amounts of things you can do. There's also a competition going on of who can read a large file the fastest. That was just reading fastest Java competition. I think this was it here. No, so it was on Twitter or X nowadays. File.io. I'll find you a link for it. I might have even posted it here. They're like, how fast can you get this much data processed out? It's a bunch of temperature data and average it, essentially. And you can do it it was like a multi-gig file. They're getting it down into less than 3 seconds in Java. And they're like, hey, we can do it in C# too, because people are like, hey, C# sucks. And everyone likes to bash on it for some reason. And the C# folks are like, yeah, we can do it too. So that's really cool. So if you like that sort of stuff, if you like competitive programming, fast things, there's stuff out there for you as well. Right, that was a fun. I go down rabbit holes all the time. I apologize. We'll figure it out here. Yeah, and then the last little bit we don't get into. This is if you'd like to do the last little couple things here. That's just fine. I assume you know how to debug. I assume you understand compiler errors. These sort of things. If you're not super strong on it, go check it out. It's like $30 for the book. Definitely well worth it here. He does a nice job of it. All right. So let's see if we can't play with some of these things. So making variables. Right, we have doubles, right? Doubles are doubles. They're pretty easy. Some number here, 4.2, sure. I have an int, some other number is 1, sure. Right, what's it not like? Oh, Visual Studio is amazing here. It's telling me I just made a variable and I'm not using it. Like, slow down, right? I haven't got there yet. If you like keyboard shortcuts, CW and then tab will type out for you console write line. This is your cout. Essentially, again, or you can copy paste, or you can type it all out yourself if you like. Whatever way you'd like to get these things, great. I'm going to use all sorts of shortcuts here, so I can output my some number, and I can console write my some other number here, and then those warnings go away. When I run my program, I get 4.2 and 1 and hello world. Nothing super exciting, but I've got variables, right? They work the same way. Strings, we have as well. You don't need to ask to use strings. You don't need to include a string library because C# is like, everyone uses strings. You should always have strings. Yeah, sure, why not? So, name here is Eric Chernesky, semicolon on that side, there we go. And then again, console write line, it's suggesting name. Look at that, it's so helpful. It's like, you probably want to write your name. Yeah, I do. Then we get our name out. And those sorts of things. So you can't do weird things like I can't do name times some other number here, right? Or bad arithmetic doesn't work, unlike JavaScript, which lets you do this. Python lets you do this. C# gets really confused because it's a normal kind of language. You don't get this sort of thing. It's like, hey, operator star cannot be applied to operands of type string and int. And these sort of compiler messages you're probably used to seeing in C++. When you do dumb things, it tells you did a dumb thing. Or when you tried to do something clever, it just gets confused. That's all, right? So if you want, you can concatenate these things together here. So name plus some other number, though. When you have a string and you use the plus sign, right, you get concatenation. You get stick something on the end here, please, right? It's not actually addition because it knows it's a string. You can't add strings together. That doesn't make any sense, but you can concatenate a string in something here. So now when I print that, I should get Eric1, right? It took the integer and automatically assumed if you want to add that or concatenate it to a string, I probably should make it a string for you. And it turned it into a string for me. So it does a lot of things behind the scenes for us, which is nice. Occasionally, if you're not used to it, you might be confused, like, why can I add an integer and a string? Well, we're not adding. Yeah?
Is there a way, like, would you do, like, \n to, like,
yeah.
write that space?
Yeah, so if, or you just, if I want to quote here, you can add in new lines if you wanted, right, your \n for new lines. I've been told the better way to do this instead of \n's is environment.newline. Because environment.newline will be specific to Macland where you get \n's and \r's, or Windows you get one or the other, and I don't know why we have different returns, but sometimes you have a carriage return and a new line, and sometimes you just have a new line. So this is supposedly better, right? Better than \n, right? This environment new line. Sure. And look, occasionally I'll put comments in. I hate comments. I've got a really bad habit from industry where we think comments are stupid because if you have to add comments, our rainbows and unicorn world is your code is bad. And you could write cleaner code that's more obvious to what it means. There are really good times to use comments. And sometimes things are just nuts and you have to add a comment. But the default should be you don't need comments because you can read your code, even if it's not always 100% true. But the exception should be I have to add a comment here, only in really special cases. And you can make really long variable names. Some people tell me really long variable names are dumb and obnoxious because you have to type a lot. I've never typed my variable names out, right? You just type a couple letters like some other number and you up and down and then hit tab and it types it for you, right? If you're typing your variable names out, you've done it wrong, right? Let the tool work for you. So those sorts of shortcuts. Yeah, so now we should get a new line here when we print out Eric Chernesky in 1, but we've essentially concatenated those together. So it turned it into a string for us behind the scenes. Other silly things here, so maybe we have, I don't know, like an int for number of credits, 27 credits or something, and then we have an int number of credits required. Required for degree is 60 here. Actually, no, this is 9. I think I have 9 doctoral credits, and I needed 60. So if you want here, because putting things into strings is so common, we have a shortcut, right? We love shortcuts. So console write line, when you make a string here, you can use this $sign and you get string interpolation. It's a fancy word for it will interpolate variables and throw them into your string for you. So you can say Eric has, and then use curly braces because no one ever prints curly braces in strings. So they said, hey, this character probably means this here. That's fine. So this will be my number of credits in curly braces here. And notice it's highlighted unlike the string color. Right? We give it a visual cue. This is my variable here. Credits out of, and then my screen, I'm zoomed in a little bit here. Generally, you don't want to go too far off to the right here. So I'll just bump that down one here. Out of number of credits required. Number of credits required for degree, and use your arrows and tab for autocomplete here. It's fantastic. So this here is going to give me string interpolation. Interpolation? That's probably spelled right. That's with the $sign. Right? So you can throw variables right into your string, and C# says, okay, I'll turn it into a string for you. You don't have to do any conversions. You don't have to do concatenations with plus signs, because plus signs are hard for people to read, that sort of thing. You get to see, here's the string, here's what I'm substituting in. right? And we run that, we can see, hey, now I have 9 credits out of 60. Wah wah, right? You only get 5 years to finish, which sucks. So even like if you get an extra year, like if you don't finish in time, you're out of luck. Really, academia is a really weird place. So, okay, well, we're dealing with the system we're in, so we'll figure it out. Okay, so I can do string interpolation, I can have variables. Now, these are types. These are built-in types. These are technically known as primitives. Notice they're lowercase in this dark blue. They're the primitive types, right? My basic types, my booleans, my integers, my doubles. String is technically considered a primitive type. There are also class versions of these, right? So if I want to do something fun, I can say integer dot, integer. Did I not get, where's my integer class? Double, all right, double, sure, double's here. So double has double dot, the double class here gives me all sorts of cool things I can do with doubles, right? Double dot pi, if I want the value of pi here, right? I can go get that back out, right? So we have these wrappers around our primitive types for the class types that give us extra functionality, all the cool things classes can do, like have functions and methods and have values, right? The regular doubles don't do that for us. So you might see that occasionally. We can write that if we want. We'll just console write line, our value of pi. Can't wait for pi day. And if I add my $sign, right, we can throw that in here, and we can print out pi. I think it's like 15 digits we get or something, right? Is that, I don't know how many that is, probably close to 15. Sizing, it works the same way, right? I think this is 8 bytes or something like that. You don't care too much, right? We're not going to use millions and millions and millions of these things, so I don't care if it takes up more memory, because my machine has billions of bytes. Right? We're going to be lazy because we have really powerful machines nowadays. We don't really care that much about memory. Later, you can go care about it, and it's important and those sorts of things. But for now, it doesn't really matter. All right, so here's my pi value here. Let's see. So some other things we can do with variable names. Did you ever work with auto variables in C++? Anyone show you auto? No? Okay, so auto is like, hey, C++, you figure out what kind of variable it is. In C#, it's called var. So I can say, hey, var, this is some integer, equals 2, and now var says, hey, figure out what type you are based on what I'm assigning. If you're assigning an integer, you're probably an integer, right? If I hover over some integer now, it knows it's an int. I see this little int helper type here. If I change that to 2.0, now some integer is technically a double, which we've done a bad thing because now my variable name is wrong, but this idea, it will change based on what you assign it, right? If I manually put in here int some integer equals 2.0, now we get our compile errors, right? It says, can't implicitly convert double to int. It doesn't fit, right? No good here. But if we went the other direction, we said, hey, double some integer equals 2, C# is like, sure. 2 fits as a double. It's 2.0. I'm okay with that. So again, it will auto-fit in larger types, but it won't auto-fit in smaller types, right? If you use explicit variables, if you just use var, it figures it out for you. And you say, hey, var, last name is Charnesky. I should know what my last name is here. And it knows, hey, last name is now a string. Yeah.
Can you change the type later on, like assign it to something?
No, so once it's been assigned, I can't now go say like last name equals 2, right? This will error because it's technically a compile time shortcut. So when it compiles, it assigns the type based on this line here. The rest of the program, it's fixed at compile time. Yeah. So we can't go change it. So it's not like Python where you can start changing your variable types. So it is still strongly typed. Var is just the shortcut for, hey, compiler, you know what it is because you have the thing on the right-hand side. Right? So a lot of people like using var everywhere because it saves them 3 characters of typing. Sure, that's fine. Later on, we start working with like crazy interface types and these really big things. Var is really helpful because you don't need an IEnumerable of type student or all sorts of nonsense things for lists of type things, and it's really helpful. So it works out pretty well for us. So that's our types here. Let's see. I jumped too far ahead. I got excited. Types, yeah. Text, floating points, bool. You get bool as well. Parse methods. Parse methods are helpful. So if you want to get input from the user, we don't have cin. What was cool about cin is if you said cin and the variable was an integer, it would read an integer or try and then crash if it didn't work. Right? When we use console, so the console class to get some input here is we're gonna write, please enter what do we want here? How many I'm really hungry, so I really want to eat something. So what do I want to eat? Servings of salad you want. I don't really want salad, but I'm supposed to eat salad. It's good for my diabetes. So I'm going to pretend like I want salad. Okay, and I'll have an integer for servings of salad. This is making me depressed, even just putting it here, but that's okay. Now, again, I don't need to give it a value. Right? I don't have to initialize it. I can just declare it like we did in C++. Here's a variable. I'll go assign it later. Right? So to assign it now, I can say servings of salad is equal to console.readline. Readline, goodness gracious, too much tabbing. So right now it's upset with me because console readline returns a string. Everything we do with console for reading stuff is string based. I can't say, hey, you should know that it's an integer, give me an integer. That's the one downside. You'd think it'd be a little smarter here, but by default everything's a string. Where with cin you could say cin a variable and you'd get that type if it could, right? It did some implicit parsing for you or converting for you, which was nice. So we have to do the manual parsing here. So if I want this as an integer, it's integer.parseInt. int.parseInt. Oh, int.parse. There we go. Int.parse. This is weird. Sure. Goodness. Console readline. Console. I think I'm trying to type too fast here. I might have had a little bit too much coffee, believe it or not. I'm a little bit jittery, which is good. It's really good. Yeah.
Wouldn't you want to do try parse in case you have an exception that comes through there?
Yeah, we haven't talked about exceptions yet, so I was going to skip the try parse until we got there. Yeah, so trying something and handling an exception, which hopefully you've talked about exceptions before, is better so you don't crash. Nothing pisses people off more than having their program crash. I don't know why, we just have no patience anymore. But I still get upset when my apps crash, and like I know things are hard sometimes. But yeah, so if you don't give it an integer, bad stuff happens. That's okay, right? And then we can console write line. Eric, go eat your serving. Oh, I need my $sign here. Servings of salad. Servings of salad. Sure, that's super exciting here, right? But now we should get some input here. So it's just waiting here, just like when you did see it. It just sits and waits for you to type something in, right? So if I want 4 servings of salad, now it says go eat your 4 servings of salad. Very exciting here. And what is it not like? Read line. Possible null rep. Yeah, if you don't give it something, bad stuff can happen. Null handling is a little bit awkward. We'll get more into that later. So right, it's just a warning. It's not an error, so we can just ignore it and run it anyway. Yeah.
Can I just ask why you wouldn't use ternary expressions?
Oh, they're great. If you like them, go for it.
Okay, I just wanted to make sure.
Yeah, so generally I find people are confused by ternary expressions because I get confused by them because I just never remember, do you do the colon first or the question mark first? And then if I have to stop and think about it, I'm like, I could have just done an if else.
Yeah.
Sure. If you do them enough, you just know, hey, I do my question mark first, life is good. Twitter's a weird place, but there's a really good tech presence on Twitter or X. Do we care it's called X? I don't know if anyone cares anymore. There was a debate on whether or not you can use nested ternaries. And they're like, hey, I like this code. It's like 5 different ternaries after each other. And I'm like, this just makes me feel awful, and I want to throw up on it. And other people are like, this is amazing, I love it.
They're more efficient though, too, with runtime. That's the only upside.
So it'll compile to the same thing in C# for us, right? The compiler takes care of all those things for us because it's an if else. It does it the same thing. All right, so we can start reading values out and doing something with those values, right? We can do arithmetic here, those sorts of things. If you want doubles, right, double.parse double or double.parse, right, we can convert to doubles. Those sorts of things are pretty easy. Read line, right? So turning strings into values is useful if you want to do arithmetic. If you don't need to do arithmetic, leave it as a string. Right? It's not going to hurt anything as a string if the only thing you're doing is spitting it back out. But if you want to do some arithmetic and figure out how many servings of salad you've had in the day to make sure you fit your food pyramid and that you'll make your nutritionist happy, then you can do arithmetic here with it, that sort of thing. Again, just depends on what we're doing with it here. So we've got our types, we've got convert, we've got parse. Those are handy. Math gets to be fun in C#. So you might have done before, so if we console write line 5 divided by 2, You all know what 5 divided by 2 is? I don't need this double one here. I'll comment that one out. Now let me go eat some salad. You remember 5 divided by 2? Everyone knows that one? It's 2, right? Obviously. It's integer division. If you take an integer, divide by an integer, C# says you must want an integer, right? So you don't get a double unless you have one of the operands as a double, right? So if you're doing basic arithmetic with integers, sometimes you get really weird stuff if you're not careful, right? So just be wary. Integer divided by integer equals integer. Go bye-bye decimal place. Sure, that sort of thing. We can do that. But again, if you wanted like 5.0 divided by 2, now we can actually figure out what the actual number is, right? Which is, right? This is not super exciting, sorry. 2.5, yay. But now we get a double result because one of the two operands was a double here. So we can do that. Order of operations, I really shouldn't have to tell people who've gotten through at least Calc 2 how order of operations work. But every time I'm surprised by someone who doesn't understand how order of operations work. And it hurts my head, right? So when you say, hey, I want 5 divided by 2 plus 3 times 5 minus 2, or where do they? I think they had the times in here, right? I think it was this one, something like this. Maybe we'll do plus 5 minus 2. I've legitimately had people tell me before that you should do 2 times 3 first, because when you say PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, multiplication comes before division. And I just want to cry, right? We all understand multiplication and division have the same level of precedence. But when you speak, something has to come first. Okay, I don't need to spend a lot of time on this. Good, you folks are great. So yes, left to right based on your order of precedence. If you want to multiply first, add your stupid parentheses. It's not hard, right? Parentheses go first, okay? Then exponents, then multiplication and division. Say it really fast to help the dumb people. Then addition and subtraction, right? Left to right. Works the same way you'd expect it to in math class. Now, you get those silly things like, hey, no one can solve this here. What is 5x divided by 2 times 3, or some nonsense like this. And I blame math teachers, because 5x really means 5 times x, right? The multiplication sign is implicit there. Just because it's touching doesn't mean it has a higher level of precedence. Right? So I'm probably doing this wrong. It's 2 divided by 5x, right? Or something like this, times 3. They're like, oh, you have to do 5 times x first because it's touching. No, you don't do 5x first because it's touching, right? It's 2 divided by 5 times x times 3, right? Just because it touches, there's no parentheses there. If you want 5x, put it in the stupid parentheses, right? Okay, that's enough time to spend on this. It's not hard, sorry. Irritates me. A lot of things irritate me, I apologize. Your combined assignment operators are shortcuts here for if you're changing the value of a variable, plus equals, minus equals, divide equals, times equals, they work the same way they've done before. Plus, plus, minus, minus, your increments and decrements work the same way. You can also pre-increment or pre-decrement, which someone once told me was faster and I just didn't care. It's not worth my time to change my plus pluses to plus plus values. It doesn't matter. Int max value is really fun. If you don't know what the max value is here, right? Please, please, please use parentheses if you want them. Okay, so we can say, hey, what is the int max value here, or the min value? Right? What is the largest value? What is the smallest value we could have here? Because it's really not worth remembering here. I typed A. Input string A was not in correct format. I meant to type 1 and I hit A, so I crashed it. Now I'm sad. 1, there we go. 2 billion some odd, right? The same thing with C++. Same max values, they're the same size values here. No surprises there. But we have these nice little constants for them, essentially, if you want them here. Now, other fun things you can do, like 5.0 divided by 0. That's an infinity sign. How pretty is that? It doesn't crash. It knows 5 divided by 0 is infinity. Sure, okay. Weird stuff will happen if you divide by 0, but it won't crash. Sometimes you want it to crash and it doesn't on you, so that's a little awkward here. But 5 divided by 0 now, right? If we do integer division, won't even compile. Okay, can't do this one, can do this one. I don't know why. Just you'll run into weird stuff like that, and that's okay. Things happen. So you also can sometimes get positive infinities and negative infinities. If you're dividing negative numbers by 0, you get negative infinities. You can get nan, or not a number, depending on what you're doing here. That's okay, right? Weird stuff will happen. That's fine. Not too big of a deal. If you like casting values, you can do the static or regular, not even explicit casting. Say, hey, take this value, turn it into an int, please. Right? When you take a double, turn it into an int, it just whacks the decimal place. Works the same way. Other fun things, we've got the math class or math F class. You can do pow and square root and sine and cosine and all sorts of math things here if you like math stuff. Some people really like math stuff, some people don't. My brother's best friend in college, he's older, he's the reason I got into computers because he's 7 years older than me. His best friend got his master's and his entire thesis was on how to draw curves efficiently. Turns out he got a job with AutoCAD, go figure. Right? They like drawing a lot of curves when you do engineering modeling. And doing them right and efficiently makes your program faster and makes your designs better and those sort of things. So he still apparently draws curves for a living. Just a very weird specialty. Like, I do curves. Okay, I didn't know that was a thing. Sure. Operators, I think we're good on this one here. Your unary operators, plus and minus, right? You can attach a plus or a minus to things. It won't give you compile errors if you say, +2. It's still just 2. Right? It's positive 2. So again, weird stuff can happen. Updating our values, I think we're good there. Types, overflows, rounding. Adding weird stuff, right, to int max value. I think we've done that one. Did you do that one before in C++? And you see what kind of garbage you get? Max value +1. Uh-oh. It's no big. It's too big. Overflows at compile time in checked mode. Likes to check these things for it. You can actually turn this off. And you can say, please don't check this. Let me do a dumb thing. I don't recommend it. Right? But occasionally, you might have a value here. Like here's a int for max value entered. Console.readline. Oh, sorry. Line. Nope. Console.read. I thought there was a shortcut. I'm not remembering what it is right now. Please enter. I want to be able to copy paste this thing. So int.max value. Okay, we'll tell them to enter that, and then I'll take max value here, and then I have to convert it int.parse of this thing here. Sure. All right, so now I can have this as a variable, and I can overflow it, because at compile time, it doesn't know that I'm planning to do a dumb thing. You never plan on your users doing dumb. We probably should plan on our users doing dumb things, and make sure we're robust and can handle errors well here, because users do the weirdest thing. Poor guy, he got his account locked out because he kept trying to log in over and over and over and over and over. We had no idea what was happening. Turns out his cat walked across his keyboard. We got this poor guy's image, his computer re-imaged, because we were like, did you log in a bunch? He's like, no. And they're like, IT was like, you probably have a virus. We should reload your computer, because his cat walked on his keyboard. We're like, it tripped our alerts here. You logged in a bunch. All right, so here, please enter this value. I'm just going to copy and paste. I add 1 to it, and I get the negative. Again, we've overflowed. We've done a bad thing here. Not great ways to deal with this. Right? You can do your usual tricks and check to see if your value's now all of a sudden very, very, very low. You've probably done some weird arithmetic. Right? Or you could just be lazy and use longs. Right? We had the long integer types, or you had longs at some point if you really wanted them in C++, because long wasn't long enough. You needed a long. Sorts of crazy things. So sure, you can use longs, right? Long integers here. And then we'll say, hey, this is a long value here. Now I can add 1 to it. Sure. Right? Not super interesting here. But again, if you wanted to know what long was, you've got a min, you've got a max. We can see what the max long value is here, because that's fun. This is a really big number, if I remember right. This is not the kind of thing I keep in my head. We can copy paste this in, and +1 should actually work now because it's long. Okay. Is that like 9? There's thousands. There's millions. There's billions. There's trillions. There's quadrillions. 9 centillion? Is that the right for 5? Yeah, sorry, you just holler at me. I'm staring at my screen here.
Sorry. I missed what parse says. Does like PRA.
Yep. So parse is for converting. So when we use console readline, we only ever get strings back out. So if you want to do arithmetic, we have to convert them to numeric types.
Okay, sorry.
Yep. Yeah, no worries. So sure, if you have more than 9 centillion of something in your code, I don't know what you're doing. Go for it. Have fun. A fun story, if you like fun stories, because who doesn't love fun stories, right? It's really boring to do only code the entire time. I believe it was the NASDAQ stock exchange. I think it's NASDAQ. Maybe one of the big stock exchanges here. Because stocks are traded in fractional amounts of pennies, they decided that it's more efficient to store whole numbers of fractional pennies. And it's true. Dealing with integers, computers can do math much better, much faster than dealing with floating point numbers. And if you remember anything from dealing with floating point numbers, occasionally it screws up and you lose a zillionth of something. If you lose a zillionth of someone's stock, they get pretty pissed at you. Right? I mean, so sure, that's a bad thing. So they're like, hey, we should use integers here. So they multiplied everything by 10,000, right, to get 4 extra zeros, because they have up to the hundredth of a penny, right, of dollars. So it was hundredths of dollars was their unit of measure as an integer. And Berkshire Hathaway stock, thanks to, oh my goodness, what's that old guy's name? The investor, Warren Buffett, never split. So their share price was ridiculously high, and it overflowed in the integer value that could be stored in the application and in the database. So they had to change the software because Warren Buffett refused to split his stock because he wanted Berkshire Hathaway stock to be worth a ridiculous amount of money. Because you can. Right? When you're rich, you can do whatever you want. Mostly. Not, okay. You understand that was an exaggeration, but only slightly. Okay. Yeah, what was his stock price anyway? Hathaway stock. Yeah, it's like the 500,000 now. Yeah. So like in the last 5 years or so, right, it went from 300,000 to 500,000.
I'm pretty sure they have an A and a B too, Berkshire.
Yeah.
A and B.
Yeah, different stock classes. Finance is fascinating. You can make a lot of money doing finance work too, which is fun. Yeah, back in 1992, you could have gotten it for a bargain of $8,400 a share. That's 40 years though? No, 30 years worth of return. I don't know if that's actually a good amount here over that many years, right, due to inflation. It's decent here, but inflation sucks and eats away your earnings. That's a whole other story. We can talk about that another time. All right, overflows, right? We did some of that. Math class, great. Math.pow for doing powers, right? The exponent operator doesn't work, right? You can't do 2 to the 5. It's not going to do what you expect it to do here. 2 to the 5, 7. It doesn't do exponents. So the caret operator here is actually doing. This is a bitwise operation, I think. I never touch this sucker because it's obnoxious. I think it's a C# caret operator. What is that doing? I think it's bitwise. What does it do? Thank you, Stack Overflow. Here's the duplicate. It is a bitwise XOR. If you haven't taken 310 yet, that means nothing. If you have, you probably forgot what it means. That's okay, right? No one cares. A couple people care. I'm really glad a couple people care. I'm trying to be a little bit funny. I'm not a very funny person. I apologize here. If you like those sorts of things, I'm not meaning to insult you at all. I promise. I'm just trying to be silly because otherwise it's a really, really, really long night. Okay. All right. So we got our bitwise OR operator there. Bitwise XOR operator. Don't do it. Okay. Fun fact though, if you like C# and I think the guy who still teaches 310, it's language agnostic. You can use whatever language you want. Doing projects for 310 in C#, it's amazing. So good because there's so many good shortcuts here. Doing it in C++ sucks when you have to do those projects. So just an option for you out there. Ask your prof, but way easier to do all that stuff in C#. Way easier, I promise. Okay, so let's see, I think we got through all the variables we wanted here. More math stuff, that's fine. Console, yeah. Other crazy things you can do. You can change colors. You can make it beep. Beep is fun. Why not make it beep? Changing colors is key. Where's the beep here? Console.beep, and you can give it frequencies and durations. Why not? This is fun. So we'll make the console beep here. Make the computer scream at us. I probably should say I copy-pasted that, but it was not an interesting piece of code. Oh, did I not hear it? My volume's up really high. It should work. I might just not be hearing it. I'm not hearing it. Usually it beeps. It might be my laptop or something. Your mileage might vary. Making your program beep at your user, it's cute. No one really cares. But sure, it's out there, and it's built into the library, because who doesn't put this in their console library? I don't know. They do fun things here. Escaping, right? You can escape characters with the backslash, just like you can in C++. Your backslash character is the escape character. If you want an actual backslash, you do //. That's all fine, well, and good here. If you don't like backslashing things, if you don't like escaping things, you can use the @ sign, which is the verbatim string literal here. So when I console write things and say I like to use a lot of backslashes because they are fun, and throw in a bunch of backslashes around here, right? Weird things happen because they're not escape characters. It's like, I don't know what this thing is, but if you put an @ sign here, the string literal verbatim. Verbatim? That probably spelled that right. It's like, oh, okay, you want literally every character you put in here. I won't try and do anything with it. Sure, go for it. I don't know why you'd want to do that, but you can. Got options. That one's fun. The string interpolation, I love doing string interpolation because having to concatenate things with the plus sign is obnoxious, right? Especially when you have to like end your sentences with periods because you want your program to look professional, right? Everyone ends with periods, right? We always end our sentences that way. You text message in full proper English, right? You don't abbreviate anything. A friend of mine sends every text ends with a period in full sentences. I think he does it to annoy people on purpose. But it annoys me for some reason, like, man, why are you doing this? He's like, I just like doing it. So sure, go for it. Different paddings and alignings, all that the formatting you can do for standard output formatting you can do. Go look it up. Just go Google, how do I left align things or right align things or add padding? It's not worth memorizing any of that stuff. All right, if else stuff, fantastic. We're okay, moving on, right? That was probably way longer for a variable intro than we needed, but there's lots of like fun things that happen in C# you might not expect. So a little bit of stuff here. All right, so hey, if my 10 is greater than 7, else do something else, right? Yes. Otherwise we'll say no. I don't know why, right? Boring if-else stuff here. Now, right away, it's warning me, hey, this never gets here. At compile time, it knows this code will never run. Right? We didn't ask for variables here. Probably should ask them for like if number of servings of salad, right? Servings of salad is greater than 7, print, whoa, Nelly. That's too much. Otherwise, good job. Right? If you eat more than 7 servings of salad in a day, you're going to be in for a bad time, right? Okay, it's just too much fiber. It's bad for you. Believe it or not, everything in moderation, even the good stuff in moderation. So great, so we can do this if else. Super boring. It works the same way. You don't technically need your curly braces if it's a single line here. If I see this, I will make fun of you because it's not hard to put in the curly braces. It's better practice to put in the curly braces, in my opinion, and of course I'm right, obviously. Years ago, you're all probably too young to remember, the Safari browser had an SSL vulnerability that if you went out to a secure website, it actually could be broken into, and your connection could be broken into, because one of the fine developers at Apple decided they didn't need to use curly braces. Literally, it was the lack of curly braces that caused this SSL vulnerability. They had to patch with this urgent hotfix out here to make sure you could have secure browsing on Safari. And I still tell this story 15, 20 years later because you should use curly braces, okay? It's not hard to use curly braces, I promise. We'll just agree to always use them, and life will be good here. If you don't, it's okay. You're not going to lose points here. back when I took my very first programming class in college, I had done a little bit on my own as a kid because my brother was into it here. Like I knew a couple things, but I wasn't super sharp or anything. I really liked video games instead. I was like, I want to do video games for a living. Turns out writing video games is really hard, and the industry kind of abuses you, and it sucks, and you work really long hours. Occasionally, you make good money and make good games, and your name gets in the credits. So, and the industry is getting better for everyone who's in game design, right? The industry recognizes it's a problem. We're trying to get better, and there's good places out there who take care of their people, and then it's not all the CD Projekt Red that works you 80 hours a week to meet the stupid deadline to launch a game that fails, and everyone gets pissed off at Cyberpunk because it was released basically as a beta. Like, we're not all there. But anyway, so my program did everything it was supposed to do for my assignment here, but I didn't get an A on it because I didn't have a comment that the prof wanted. I was like, it worked, it did all the things here, but you didn't add the comments you're supposed to add. So I swore back in 2004, I'm an old person, that if I ever had a chance to teach, I didn't know I wanted to teach. At that point, I wanted to be a IT manager and make a bunch of money, be like the CIO in charge of things, because I thought that'd be fun. Asking other people to do work for you really sucks. I found it that it sucked. I did not enjoy that. I didn't find it personally fulfilling to please ask other people to do work. Right? Management is hard. People are messy. Right? You know you're a mess. I'm a mess. Right? Maybe you're not a mess. Good for you. But having a team of messes work all together to try and get the same thing done or get things done is really hard. So bless the managers for having good people skills, doing that sort of stuff and dealing with that. It was not fun for me. So when I decided I was going to teach, I was like, if I ever teach, I will not take points off if the code works. If it works, it works. I don't care if it's a hot mess. I don't care if it's spaghetti code. If it works, you get points. And I've stuck to it ever since. I will never ask you for comments. Okay? I won't even take points off if you don't have curly braces, if you don't follow style guidelines. I don't care, right? If it works, I'll just make fun of you. And then it's fine, right? You can just ignore me because Eric's a crazy old guy. That's all right, no worries. But curly braces, just always use them. Life is better with curly braces, okay? And again, it types them for you. When you type in the first one, it types in the ending one. It's not even hard to add them here. All right, so we get our if-else. Those are work the exact same way here. You can nest them. You can have if. You can have your logical operators, your ands and your ors. Now, what's fun with ands and ors, where did that go here? Relational operators, yep. Booleans. Oh, we should talk about Booleans here too. So if you have a Boolean value, right? So Boolean too much salad is equal to, we'll say, servings of salad greater than 7. Okay, I can say now this is already true or false, right? And you can use a Boolean inside of an if because it's true or false. I can say if too much salad here. Now I've typed more things. I've done a little bit more work here, but now you know that this means too much salad. We've added a little bit of context to our code here by doing this. But oftentimes when people use Booleans and if statements, they say, hey, if this thing is true. And I just roll my eyes at you because already, if it's true, it runs. You don't need to say, does true equal true? Right? You've done more work than you need to. So again, you'll see those sorts of things. That's fine. But maybe if too much salad, and then we can say, now, you can use your and, ampersand operators for ands if you want, or you can use the word, I think I can use the word and, right? And true? Can I use the word true? Is it not working? It doesn't. I really thought that worked. I apologize. Ampersand, go for it.
Would be your operator that would do it.
Well, so I don't want to check for is usually the identity, right? I thought it C# and operator English. Is that it? And or not? Can't. All right, we can't do it. Yeah, I thought and. Okay, you can't. I thought you could. My bad, I'm hallucinating here. The double ampersand is, like in C++, a short circuit operator. So if the first thing is false, it never evaluates the next thing. Right? So it works the same way. Saves you some time here. Sure, that and true is a little silly here, but we can come back to those later, I guess. So too much salad. I don't have any other variables right now. And how about name equals Eric Chernesky. Okay, this is Eric Chernesky's limit. So if you had too much salad and you're me, then we'll tell you whoa Nelly. If you want to eat 7 servings of salad, go for it. Right? I'm only going to tell you whoa Nelly if it's me, right? Because I got to warn myself because I get forgetful here. So we can and things together if we want here. Now this should work, I think, because I think name was Eric Chernesky. right? So we'll say how many servings of salad? Let's do 8 servings of salad here. Number, we get whoa Nelly, like we'd expect. Pretty exciting here. That worked. Now, comparing strings with equal signs, it's a little bit awkward. It generally works for us here, but it's not the preferred method for comparing strings. Generally, you want to say dot equals here. We can say, hey, does this string equal another string here using the equals method? The cool thing about the equals method is you can give it other things here. You can give it these string comparison types, right? So if you care about casing, great, we can deal with casing. Your equal sign will deal with casing, right? Uppercase letters aren't the same as lowercase letters. But if I want a string comparison, string comparison dot ordinal ignore case. There's all sorts of these different ones here. I don't remember which one is which. But if you want to ignore casing, the dot equals method will ignore casing for you. Now, if your name is uppercase E Eric or lowercase e Eric Chernesky, it will still do the same thing for you here. So the equals method, string dot equals method, we use to ignore case. Super handy here, because having to lowercase everything before comparing is a little bit tedious sometimes, right? And we want to save time. So if you're asking the user to enter something, who knows if they entered it uppercase, lowercase, right? Just compare it with or ignore case. I think it's ordinal. There's another one here that ignores case. I forget exactly what all these ones are, but ignore case. Yeah, you can do ordinal, invariant, current culture. I don't even know what all these other ones are here. Invariant culture. Culture sensitive sort rules. That means something. We can go Google it if we want here. But ordinal is the basic, just use your general character sort thing here. All right. Ands, ors, nots. Good there. My goodness, it's 8:10 already? Goodness. And then conditional, your ternary operator, right? Question mark, if something, colon, the other thing. Some people love these, go for it. I generally don't like these things because they confuse me, and I don't like to get confused very often. So you can go for it. So score is greater than 70. I should zoom that in here, sorry. You passed. Colon is the else you failed. Right? Failing less than 70 is a little bit rough. Technically, D's are passing marks, but you can't get too many D's because then your GPA is too low to pass, right? Does that ring a bell for people? I think you need to keep a 2.0 to pass or to graduate, but a D plus will get you through the class to the next one, unless it has a specific prereq of C or better for those sorts of things here. And it's probably too late for all of you folks, but tell your friends, if you take calculus at community college and transfer the credit, C or better transfers and the GPA doesn't transfer. So when you apply for internships, your transcript you show them from U of M Dearborn doesn't show the C's you got in math. And they're like, hey, Ford says, hey, you have a 3.5 or better? Great. Because Ford is stupid, and if you don't have a 3.5 or better, they won't look at your resume for an internship, even if it's the math class that you're not even going to do any math anyway, because they have to have some sort of filter here. So tell your friends, transfer your community college credit later. Help out the next class behind you, but transfer credit's fantastic. I also do work for OCC, so I do get paid to teach classes there. Probably a little self-serving there, but anyway, transfer credit's fantastic. All right, switches basically work the same way. Right? You can switch off of something. Now, switching, you can do more switching in C#, right? So if you want to switch off of a string, we'll say, I think we had last name, right? We can say last name here, this way, right? So we have case for Chernesky, colon, this is not the right syntax here. Oh yeah, can't follow, that's fine. We can print my relative, right? And then break, because switches use breaks. I will generally never use switches because I don't like typing the word break. I don't know why, but generally I don't do that. And then you might have another case for, I don't know, maybe if you're Smith, we'll console right line, you are related to 2 billion people, because everyone is a Smith, or something like that. And then maybe we'll have our default case here, unknown relatives. Right, isn't it default? Is it not? Am I doing a break? Goodness, I should look it up. There we go. So here's our switch. It works basically the same way, but you can switch off of strings now, which is fun. You can switch off of integers, you can switch off of chars, you can switch off of whatever you want here. Those are lots of fun here. If you like switches, that's fine. Okay, I think switches was good. Should we take another break? And then just like 5 minutes? It's been like another hour. It's up to you folks. All right, vote for break. Vote for no break. All right, I got more for no break, so we'll just keep going here. Sorry, you guys lost the vote. All right, yeah, switches, great. A switch expression is a newer syntax thing. It looks a little weird here, but you can avoid all the break statements, which is why I hate switches. If you use your switch expressions here, the underscore becomes your default here in this case. Sure, and you could sort of like, I'm going to return a value here or assign something. It's sort of almost like a ternary, but it's a switch with n number of cases here. Think of it that way here. You'll see some crazy stuff, and that's fine. Yeah, loops. All right, loops are super easy. Do loops, while loops, for loops, the exact same thing. Right? They work the exact same way as they do. You can use breaks, you can use continues. Again, I don't like them, but sure. But they work the same way as in C++. I don't think we need to do anything interesting with loops. That's fine. Nested loops are fine. Arrays. We get a couple extra pieces of syntax here when we deal with arrays. So if we want a bunch of scores, right? So an int array of scores equals new int. Sure, I'm going to put 5 scores in here. Why not? I could go through and set, look at this, scores of 0, scores of 1, scores, come on, scores of 2, there we go. It's thinking about it here. Come on, Visual Studio. Scores of 3, and we can set all of our scores like this, right? Using array-based notation, this is nothing new here. Scores of 4. Great, now we can set some values. If you know what your 5 values are, you can save a little bit of time here, and we can have, this is a int array faster scores, right, using the array initializer in syntax. I give it all the values in a set of curly braces. So here's the 5 values here. I don't have to deal anything with index notation yet. It sets it up with some values here. This is fun. So we can have scores set up this way. And when you loop, right, we can say for int index is 0. Again, don't use I. I is a terrible variable name. And please, when you do nested loops, don't use I and J, because I get confused really easily because they look very similar here. Use a better variable name, please. So index is less than, I can say faster scores.length here. Length is a property that you can use of an array. You don't need to do any sort of arithmetic yourself. So length tells you how many items are in any array. Okay? It's not a function call or a method call. There's no parentheses here. It's just .length. It's like essentially a constant property, I think is what it is. Yeah.
Is this a dynamic array where you can add?
No, so arrays are fixed in size as well, just like in C++. So we'll look at some dynamic sizing things later, like the vector. We've got those same sorts of things in C# we can use if you like dynamic ones, which are great. So we can just, I don't know, enter the value for index, add my $sign. Great, and then we can say my faster scores at index of the index variable will equal int.parse of my console.readline. Readline parentheses. Come on, type ahead. Keep up. Right, so now we can go get a bunch of values back out. So I start them all zeros and go add some values. Sure, why not? But using the length, use array variable length property to loop. These don't have to be constants, which are nice. When you pass arrays to methods or functions, you can go get this property back out. You don't have to pass constants around like we had to do in C++. They're just much nicer to use, which is cool. The for each loop, you did for each loops in C++, right? These little enhanced read-only loops, essentially. Same sort of syntax, for in something in your array. Works the same way for us here. So if you want to print them out, we say for each int value in faster scores, sure. We can print out the value, right? Goes one value at a time. We don't need to use index notation. Remember, when you modify them, they won't stay modified. This is the read-only sort of loop here, because we're not actually accessing it where it exists in memory. Right? When we do this assignment to value, we're assigning here, which is fun. All right, making arrays, square arrays notation, setting values, defaults, bounds. Yeah, this will crash on us here, right? If array index out of bounds notation, if we say, hey, I want faster scores, index of 10 equals 10, this one won't work for us, right? We don't have an index 10 here. This one should crash pretty quick. 1, 1, 1, 1, 1. There we go. Now it crashes. Index was outside the bounds of the array. Like you'd expect, it will crash. It won't let you do bad things. With C++, you could get an index value that's out of bounds, and a lot of times be like, here's a garbage value. I'd actually rather crash, right? If I try and do a bad thing, just stop, because worse things could happen if I get bad values than just stop running here. That sort of thing. So we'll hard crash on invalid indexes. Right? That's why, we liked vectors as well, because vectors made sure we actually crashed if you try to get a bad index. Right? They add a little bit of protection there. You can do this crazy indexing. So if you want the last index of something, you don't need to do length -1. You can do _1. I don't know why, but there's shortcuts for everything here. So you might see people do this sort of thing. You can do ranges. Ranges are actually really fun. You essentially take a slice of an array. Hey, I want from 0 to 3. Give me those values. I'm going to put in a different array, or do something with a slice of those values here, which is really fun. The initializer is great. Get more examples of the arrays, loops, arrays of arrays, right? Two-dimensional arrays, those sorts of things work the same way here. If you want to use your initializer syntax, right? We're again saying, hey, here's the first one, here's the second one, here's the next one. I think that's all the same. All right, and then methods. We're almost done. This is chapter 13. We got to get to 14 and then talk about the assignment. We'll make it by 8:45. It's going to be good. You are all very excited. I appreciate you hanging out still. You're troopers. All right. Methods work basically the same way. Now, without the top level statements here, we don't need threading or numerics. I don't know why those probably got added at some point here. We can write our own methods here. If we have the one with the explicit top level statements instead of the implicit ones like we're working in here, you'd have to put them outside of main, just like we did in C++, right? If you want to write other functions, you don't put functions inside of functions. Now it gets weird here because we're technically already inside of a function. But if we start writing things that look like functions, C+ or C# is like, oh, this looks like a function. You don't want that inside of another function because that doesn't make any sense. Right? So we get a little bit of that magic happening as well for us. So if I want a void print something here, right? We don't need any arguments here, perfectly fine. I'll console write line, let me out of here, right? I can use my print something function from the rest of my code over here. You don't have to define functions at the top, because when C# compiles itself, it actually looks at the whole file. And it's not stupid like, oh, I got to line 3, I didn't read the entire file yet, I have no idea what this function is. It's like, hey, I'm going to read the entire file, I'll find the function first. It does a little bit of indexing behind the scenes, which is nice. So we can print something, or if you want to do this a bunch of times, right? For int, scream is 0, scream is less than 5. Sure, why not? Scream ++. I love when it gives me code. Come on, scream ++. We'll print something, right? And we can run that if we wanted, right? Call functions ahead. We don't need to have function headers, right? You just define they're all inline functions here. We don't need to separate things out. The compiler does a bunch of cool things for us, and almost all the time it's really good. And we don't need to do any of those crazy optimizations where we have header files that don't compile if they haven't changed, and we can link the things behind the scenes like we did with C++ that keep the object files around and don't recompile them to save us a few seconds here and there. It's just going to do it for us because it's really smart, which is fun. All right, so we can write functions. You can have functions that return values, right? Here's a string for, I don't know, favorite color. Get favorite color, why not? Favorite color. And right now I'm just going to return blue because it'll always be blue. That's easy. We don't even need to ask the user anything because I'm the user. So I can get their favorite color. And if I want to use that somewhere else here, right, I can do a console write line and say Eric's favorite color is, and we'll do our little interpolation. And in the interpolation, I can call a function here. It doesn't even have to be a variable. You can interpolate functions that return things, right? Because this will give you back a string eventually. I can take the string I got back and throw it in here. Or if I have a favorite number, I can take an integer. Like you can put things inside of things, inside of things, inside of things. It gets fun. All right, so if we run that one, one. Let me out of here a bunch. Eric's favorite color is blue. What we'd expect to have happen, right? I think no surprises. I should write the new code at the top. I probably should have been committing stuff too for a while here. So I've got my program here. So here's a commit. Why not? We'll commit and push. That way we can look at the very end what it looks like when it's a little bit different. All right, so functions, great. If you want functions that take arguments, easy enough to do here. So we'll call this one a void say hello, and then string is name. And then we can console write line. Nope. Console write line. Come on. CW. Why is it not? Console.write line. Where's my shortcut? $. Hi there. Name. Very exciting, right? You pass an argument. We've defined this as a parameter. Technically, they're different, right? When you give it a value, you're giving it an argument. When you define it in a function, it's a parameter. Most people don't care. We call them the same thing, functions, arguments and parameters. No big deal here. But now I can also like say hello. I can give it my name, right? Say hello, give my variable for name, and life is good. Okay. Now, when you have variables with the same name, weird stuff happens, right? So I have this name variable from up above here that I called name, way up here at line 9, right? I also now have a function that takes an argument for name here, and I'm printing name. This name is the parameter name, not the variable name that's up above, right? So when you deal with scope and the resolution of variables, right, we're looking at the smallest scope first. So it will look in the function for something with that name first. If it doesn't find it there, then it will look outside to find the next variable. Works the same way, right? So if you use the same name for things, it doesn't matter, right? It's going to use the argument we gave it here. Maybe we should be okay doing that here. All right, so we can do ones that take values. Now the other cool thing, did you guys do default arguments in C++? No? I'm pretty sure we do those. It's a little late to remember all the things we do in CIS 200 at this point right now, but you can say, if you don't want to give me a name, right? Probably the common way you've seen of doing this is we'll have another method called say hello that takes no arguments, and to do this one, we'll call the say hello method given no name, right? We can overload our methods here with different lists of parameters. Now, this is a little bit confused here. That's okay, because we don't do it this way in C#. You might have seen that you could do it this way in C++. So in C#, instead of doing all that extra work, we can just say, hey, the default value for name is no name. When I define a variable, I can give it a default value. If you want to give it a name, we give it a name. If we don't want to give it a name, we can call essentially the overloaded version of that function that takes no arguments here. So instead of having to do a bunch of overloading here, we can use defaults. Right? Now the weird thing that happens here is if you want to use defaults and you have lots of variables, the order really matters, right? Typically when we call and we give arguments to functions, they go in order, right? It's based on the position. They're positional arguments. The first thing is the first thing, the second thing is the second thing, the third thing is the third thing. So if you want add 3 numbers together, because why not? So int first, int second, and int third here. Right? If I want to add 3 numbers, and we'll just console write line, first plus second plus third. Right? Super exciting arithmetic here. I can't give first a default without giving defaults to second and third. Because how would the compiler know that you didn't want to give a value to first, but you wanted a value for second and third? What if you really wanted to give a value to first and second, but not third? Right? So positional default arguments have to go at the end of the list here. So first might be required, and then maybe second could be equal to 0, and maybe third equals 0 here. So the default arguments, default values, to be the last ones, right? The last ones in your list, because it's all based on if I give it 1 value, it's first. If I give it 2 values, it's first and second. If I give it 3 values, it's first, second, third, right? Because that's the way it matches them by position here. We do these things here. We add 3 numbers. So we can do those. Let's see. Our expression-bodied methods are super fun here. They don't make a whole lot of sense until we start doing stuff with classes here, but you can do an expression-bodied method to say, I want to save a little bit of typing here. So the idea with that, where's the example here? I just want to copy paste because we're running low on time. Returns, yeah, that's fine. Overloading, fine. Expressions here. There we go. So we can replace this code here, 3 numbers, let's say with expression. So instead of giving it this thing here, we give it an arrow. I don't know why. Someone came up with this. It's okay. You just enter down a little bit here, and we'll say, goodness gracious, we'll say first plus second plus third. So a lot of this is like essentially the implicit, oh, this isn't void, sorry, this is an int here. So it's implicitly giving you the curly braces and saying, I'll return this value. So if it's just a straight expression, here's like a one-liner, essentially. You can do it as a one-liner without curly braces. Save a little bit of time. We'll do a lot of this later on with the more advanced code. You'll see these expression-backed methods. They're fancy and fun. Does the exact same thing, right? If you use the curly braces and say return all them together here. Does the same thing. We'll make this an int here instead of printing. We'll return. Right, return. There we go. Okay. Does the same thing as this one here. It just looks a little different. That's all here. Maybe we'll arrow that one down or enter that one down a little bit again too. So white space is hard. You might see expression-bodied methods here, which are fun. Recursion again works the same way. All right, we can wait on memory management. We don't have to do that right now. We gotta get to the assignment. We got 15 minutes here. I promised you a game. This is one of the favorite games we play here in America. This is pay your taxes right or go to jail. You have to guess the amount of money you owe the IRS, otherwise you go to jail. Now, they give you a formula for it. So you don't really have to guess here, but we have to follow the formula and get the right number and give them the right amount of money, otherwise we go to jail. This is a very popular game here in the States, and the tax return companies make a lot of money off of this game because people are scared of going to federal prison for cheating the IRS, which is probably pretty reasonable here, right? No one wants to do that sort of thing here. So what we're going to do is we're going to build a federal income tax calculator to help you win the game by paying the right amount of taxes and not going to jail, right? That's how you win, essentially, right? You don't go to jail. Right? When you're rich, you don't go to jail anyway, so that's how you win too, right? Even if you don't pay your taxes, because your tax department and your tax lawyers and your, I don't even know what they call these people nowadays, tell you, so a fun fact here, tax avoidance, perfectly legal, celebrated. We think people who do tax avoidance are amazing people and we celebrate them because we're weird. Tax evasion is illegal and you go to jail for. So avoidance is I'm following the letter of the law exactly and hiding as much as I can in all these different things that we have special laws for because lobbyists work for rich people and we write special laws for rich people. You can do tax avoidance. Fantastic. And we're like, hey, you paid no taxes. Good job. You must be really smart, even with your millions of dollars. Okay. Sure. That's weird. But tax evasion is not following the letter of the law and not paying the right amount of taxes. Now you go to jail. So, fun fact there. So there's this website here. My goodness. It is tax brackets, MoneyChimp. I think it's MoneyChimp. There it is. So this one is probably the best explanation of how taxes work. This is the weirdest thing, and I'm going to tell you a story about a student. I'm not going to tell you his name here, but I like this assignment here because it's a practical game we can play here. Everyone pays taxes who works, which will probably be all of you, I assume, because you want to go to school to make a lot of money here. He told me his dad is a software engineer, and it doesn't work this way. I emailed him the IRS file. Here's the code from the IRS. I never heard back from the kid. Never talked to me again. So don't tell me your daddy said I'm wrong, please. It's just embarrassing for you. Okay, I'm not always right, but this one I know how it works at least. So, okay. So for tax brackets, the way our tax system works is a progressive tax system, or the way it's supposed to work. This is only for earned income, not capital gains. Again, because rich people get to lobby to write tax code special for them, so capital gains are taxed differently at lower rates than your earned income here, which most of us have earned income because we don't have capital money we've invested to get capital gains. Or you're not an executive who gets paid with capital stuff, so you don't actually have a salary, you just get a bunch of stock. Sorry. This stuff is nuts. Apologies. Anyway, so as you earn your income, the more you earn, the higher percentage you pay in taxes on it. But it's progressive. So if you earn $50,000, you would say you're in the 22% tax bracket. That does not mean you paid 22% of $50,000, right? Anybody and everybody pays 10% of their first $11,000 they earn after deductions, which standard deductions is a whole other thing. We'll get to that, don't worry. So you pay 10% of every dollar. Now, when your employer withholds taxes out of your paycheck because we don't want people to have to write their own checks to the IRS because they get upset seeing how much money they have to pay all the time, right? We make employers do it for you and you just never see the money. You're like, hey, I never noticed I paid taxes. I just don't make a lot of money. And no one looks at their pay stubs. Anyway, they will estimate the amount of taxes you will owe because they say you're probably going to make this much money in the year. They don't take 10 cents of every dollar out of the first $11,000 you make. They say, hey, you make $50,000 a year. I'm going to put it through my formula here. This will be 10% of 11,000, 12% of every dollar between 11,000 and 44,725. Right? So that works out to be, well, these numbers are wrong here, but right, the top of the bracket minus the start of the bracket times the percentage. Right? You already paid 10% on the first 11,000. You're not taxed again on that 11,000. You're taxed on the difference between 44,000 and 11,000. You're 33 some odd $1,000, right? So you pay 12% of 44,725 minus 11,000. You'll pay $4,047. That is the most amount of money you will ever pay at the 12% rate. If you earned more than $44,725 in adjusted gross income, thanks to the standard deduction or itemized deductions if you have a lot of itemized deductions. Again, things like owning a house gives you an itemized deduction if you have a mortgage because the federal government likes to use tax policy to incentivize certain behaviors. And home ownership, if you have enough money to buy a home, you get tax advantages for doing that because if you're poor, you're screwed. Anyway, so tax rates, right? You don't pay the full amount, you pay at that bracket level of that. So if you land somewhere in the middle, land somewhere at 50,000, you take 50,000 minus 44,725, right? 50,000 minus 44,725. You earned $5,275 at the 22% bracket. Now you multiply that by 0.22, you'll pay $1,160 in income tax at that bracket level, right? We add that together with the 4,047 here, right? And we add that together with 10% of 11,000 is 1,100. Right? So if you earn $50,000 in adjusted gross income after deductions, you will pay $6,307 in taxes. Right? That number divided by 50,000 is an effective rate of 12.65%. This is why when they talk about some CEOs pay less in taxes than their secretary, because they look at their effective tax rate. Right? Most CEOs don't make a lot of salary. They make most of their money in capital gains because they can do that to game the system, and they pay less money in capital gains tax. Thanks to crazy laws that people wrote and lobbied for, right? So even if someone makes $1 million, they're not paying 37% of $1 million, right? So no one will ever be at the 37% effective tax rate because they've paid lower amounts at their lower income. Even if you make $1 billion, like when Elon Musk pays taxes, he doesn't pay 37% of all of it. He gets pretty close, but a lot of his capital gains and all that other nonsense, so it's much lower. But if he had a big salary, that sort of thing. So we calculate these things based on the bracket that it's earned in, okay? So what we're gonna do, we're gonna ask the user to, hey, enter the value from your W-2. At the end of the year, you get a W-2 from your employer that has already been sent to the IRS because the IRS knows how much you should owe in taxes. You just have to guess and figure it out yourself. Again, it's a fun game, right? Yeah, why not? So you'll ask the user, hey, enter the value from your W-2, and we're going to loop and let them enter multiple of them because we all have to work multiple jobs to feed ourselves because we don't make enough money at a single job anymore. So you might have 3 or 4 different W-2s. So I'm just going to keep entering values until I'm done. So some sort of loop that lets you enter values until you're done. You might have heard of like Sentinel values, or maybe you ask them how many W-2s do you have, and they enter a number and you loop that fixed number of times. Whatever approach you like, go for it. I should probably be putting this in Canvas as I go here. I'm sorry. Let me do this. I'm going to write all this down here. This is project 0. You're a normal person. You start counting at 0, right? Yeah, we're programmers. We're normal people. Give me 1 second. I got to give you a link here for GitHub. So this link will give you a new GitHub repository that is private here. Works really well. So this is CIS 297 winter 2024. All right, skip. Here's 1 sec for that link here. New assignment. All right, so this is CIS 297 winter 2024 project 0. And I have a template here. This is my C++ template. It's not actually C++. It's Git. The idea with a source control tool is you only want to put source code in there. You don't want to put executables in there because executables change every time you build it. And if you can build it, you don't need it in there because you can go click the build button. So there's a special file called git ignore in these repositories that say, don't add this kind of file to my repository. It's just junk at this point because I don't need it. So all these things like in the bin and debug directories and release directories and object directories, it ignores. So using the template gives you this ignore. If you make your own repository and don't have an ignore, when you go to add a bunch of stuff, you're like, here's your executable, here's your object file, here's your release files, here's your DLL files, and you're like, why do I have all this stuff, right? All we really care about is the code. All right. So here's our link for the assignment here. So when you click this link, it will ask you, did I already have that open? Here it is. So please submit the URL to your repository. So all you're going to give me, when you click this link here, it's going to bring you up a website and say, hey, do you want to accept the assignment? The very first time it might say, do you want to authorize GitHub Classrooms to use your GitHub account? Yes, the first time say yes, then accept. And then it says it'll take a few minutes, it takes like 2 seconds, you can refresh the page. Now you get a URL. This is the private repository created for you that I have access to and you have access to. Please use this one. Don't go make your own, right? If you make it private, you'll have to go add me, and that's a bunch of extra work. If you make it public, people will cheat off of you, and then you'll fail, and you'll be sad. So just click the link, right? It makes a repository for you. To get a copy of it on your computer, you need the GitHub desktop client. When you click on code, open with GitHub desktop, if it's not downloaded, it'll say, please download. If it is downloaded, it'll say, okay, great. Do you want to clone this repository? This is the step to get a copy of that folder on your computer. It's just a folder. So it's going to make a folder named CIS 297 Winter 2024 Project 0 - your username here. Right? So mine goes in Documents GitHub. I don't care if it's in your OneDrive. I don't care if it's on your H drive. I don't care if it's on a flash. Wherever you want to put it, go for it. Right? Say clone. Now I've got a copy of that folder. So I can say show in Explorer. I can go copy my path here. And I'm going to make a new project in Visual Studio in that folder. If you make something in that folder, it will show up in GitHub. And GitHub will say, hey, I see something here. So change your path to the thing you just copied. Right? If you see CIS 297 Winter 2024 Project 0 - your username, you got the right one. Okay, life should be pretty good. So here's Project 0. We'll go next and create. Now the GitHub client will say, hey, I see some new stuff. I see a CS file, a project file, solution file. I got it in the right spot. If you don't see anything here, you didn't put it in the right folder. That's how you know. Okay, you can always go move it later. You can cut and paste things into this folder if you want. That's fine. Visual Studio likes to put stuff in like a repos folder, in your documents repos folder. You just have to go move it. It's not hard. In Visual Studio, you can right-click on it and say Show in Explorer, and it will show you where it is. From here, you can go cut and paste it out if you want here. It's in the right folder already, so life is good. All right. So all you're going to do is turn in the URL. So when you're done, here's the URL. You should see your code here. I haven't committed anything yet, so there's no code yet, right? But if you see your code on github.com, I can see your code on github.com. It works out pretty well, assuming you've used the right link and it has Charnesky in it. If your link doesn't have Charnesky in it, you probably have the wrong repository because it's not in my organization. That's all. And this part will be the last 10 minutes of the video. If you want to come back and watch this last 10 minutes again, it's okay. It's not bad. For this part, the GitHub part, welcome to work together. You're not touching code, right? You're just moving code around, putting it places, talk to each other about it, help each other out, screen share, go for it, I don't care. Just don't write the code together, right? That sort of thing. All right, so create a tax avoidance game that helps the user calculate the minimum amount of taxes owed for 2023. Okay, I'll link this one here. This site's easier. The IRS website is weird when it looks at IRS tax brackets. It doesn't make as much sense here, and that's why I don't give you the IRS link. Like it's like all the way hidden down here. Why? Wow. I think even Bing knows the IRS website sucks for this. Where? IRS.gov. Here's the newsroom. Here you go. Yeah, this is useful, right? So use the MoneyChimp site. It's just life is easier here. Okay. So we're going to ask the user to enter X number of W-2 incomes. Right? That idea. Enter them until you're done, or tell me how many W-2s you have. Total them up, right? And then calculate gross income. Okay. All of the W-2 incomes added together is your gross income, right? Gross income. Sum of W-2 incomes. We're not even pretending to deal with 1099 incomes if you're a contractor where you have to pay extra Social Security tax, which is separate from income tax, by the way. It's a whole other thing here. We got lots of different taxes. It's not just income tax either. So gross income. Then we're going to ask the user to enter deductions until they are done. Again, X number, or just keep entering them. For deductions, that's things like donations to charities, 501c3 registered nonprofits. If you give them money, you can deduct that off of the taxes that you've owed because the federal government says, hey, 501c3 nonprofits do good things for people. We should incentivize giving to them because that's a more efficient way than making the government give money to nonprofits to do social service sort of things. right? So every donation you have to a 501c3, you can essentially deduct here. And if you get enough itemized deductions, it's more than your standard deduction and you pay less taxes. Thankfully, the standard deduction is pretty big. So for all of you folks, will bet you're using the standard deduction because it's like $12,000 or something like that, right? Standard deduction, come on. What is it? $13,850. So the first $13,850 of earned income that you have on W-2s, you can just deduct right away. Again, the tax system is progressive on purpose, so this makes it a little bit easier to be poor and not pay taxes, right? So no one pays taxes on their first $13,850 worth of income. So if you don't make very much money, you pay nothing in income tax. You'll still pay Social Security tax, still pay Medicare tax, still pay state taxes, all that other sorts of good stuff. Still pay property taxes if you own property, still pay sales tax on things, all the other nonsense stuff. I sound a little bit libertarian, I apologize. It's okay, I'm not crazy. Probably. Anyway, so the standard deduction. So if your itemized deductions, if the itemized deductions are greater than the standard deduction, use that value. Otherwise, use the standard deduction. 13,850. I don't know why I put that in quotes. That's weird. And again, this is for individual taxes here. There are other brackets for married taxes. There's actually a marriage penalty. At some point, these numbers are doubled, and at some point, they're not doubled. So if you and your spouse both work, and you make a lot of money here, somewhere in this range or so, it's no longer double, right? If I remember right. So 231,000 to, yeah. So 231,000 is double here, but if you make more than 6,393 combined with your income, you start getting into the 37% bracket earlier. Now, I'm sure you feel bad for people making $700,000 a year combined income, but again, it feels weird that it's a penalty for people who are married filing their taxes together because they both have really good paying jobs, rather than two single people not having to pay. Like if it was two different single people filing singularly, they'd be over $1 million worth of income before they hit the 37% bracket. It's weird. Tax policy is insane, and that's why there's a whole industry around it here. Okay, so we do that, and then we calculate the amount of taxes owed at each bracket. So tell me taxes owed at the 10% bracket. Tell me the taxes owed at the 12% bracket, and on and on and on. Don't tell me the total. I want to know each individual bracket amount, because we're going to break this out and be really explicit and throw it in someone's face. Hey, this is how much you paid, right? Because we get to do that. It's our fun game here, right? Then we're going to also display total taxes owed, and then we'll display total taxes as percentage of adjusted gross income. Sorry, I missed that step here. So adjusted gross income is equal to your gross income minus your deductions, right? So if you made $13,850 or less, you pay nothing. We'll tell you you owed $0 at 10%, $0 at 12%, $0 at this, $0 at this, $0 at this. If you made $10 million, you take off 13,000 of that, unless you're itemizing and have more in your itemized. You paid a lot at every bracket here, the max at every bracket, right? And then the X amount of money left at the big one, right? The 37% bracket here. So that's percentage of adjusted gross income, and then we'll also display the total taxes as percentage of gross income. So without the deductions, what percentage is it of all the income you earned before that? Because these numbers are all different and they're all fun, and people will use them in different ways when they write news articles about how much money people paid in taxes, and they won't tell you very explicitly, hey, I'm using this particular number because it makes my news story look better. I am crazy, I apologize. But here's your fun game, your very first one you get it right, okay? This will probably take half an hour here. It's not hard, right? It's just a quick little formula. Take the amount of money that you have, go bracket by bracket by bracket, right? If you made more than this, you pay 37% of the difference. If you made somewhere in between this one, you pay 35% of that. If you've made somewhere in between here, 32%, right? If you work your way from top down, right, life is really easy, because if you made more than 11,000, you pay the max for that bracket. If you made more than 44,000, you pay the 12% of that bracket. If you made more than 95,000, you paid the max of it. So it's just a bunch of if-elses. That's all it is here. When I do it, it's probably 30 lines of code or so when we're done. It's not bad. 2 little prompts for income, 2 little loops for income, 1 for deductions, 1 to calculate your total. I just go if-else through each bracket here. Here's the top of the bracket, here's the bottom of the bracket, and we're done. If you're spending a lot of time on this, stop. It's not worth it, okay? This is just an exercise, was to use some C# code here, use a little bit different syntax, do some prompts, right? We're dealing with arithmetic, so we have to do conversions, use the parse stuff. We'll go from there. I'm sorry I ran over. My apologies. If you got questions, let me know. Again, it's not worth a lot of points, and if you don't get it all done, it's really not the end of the world because later projects are worth more. This is like 10 points total for doing this sort of thing. Don't sweat it, okay? Next week. Yep. This is the only one we'll have a single week for.